All right, let's get started on lesson 2. But first, I'm going to show you something that'll make your life a little easier, and it'll be less frustrating for you because it's not going to delete all of the code that you wrote in on previous lessons. And it'll also prevent you from having to download the new code every time a lesson is released. So let's look for Git. Look at that. Just search Git, whatever web browser search engine you'd like, and go to downloads. Download for whatever operating system you're using. Since this is Windows, I'll download for Windows. And most of you will want to select 64-bit, but if you know that you're running a 32-bit system, go ahead and run that or download that instead. So we'll get that Git file opened up. Go ahead and click yes. What we're going to do is we're just going to hit next on everything and leave everything default. You won't get that pop-up, but it's okay. Just next, 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 install. And while that's going, we're going to go to the GitHub repository for the lessons, which should be in the description. What we're going to do is we're going to go to code and we're going to copy this HTTPS link. After this is done, uncheck view release notes and finish. I think that's all we need this for, so we're going to hide it away. And let's open up our terminal. So previously we'd used CD and mkdir, I believe. This time we'll use CD and we'll go to documents or wherever you want your code files to exist. And then we'll type git clone and then the link that we just copied. What this is going to do is it's going to download the code that, or the lesson code. It's going to download the lesson code. Why are we doing it this way? Well, I'll show you. Type cd python lessons, what we'd normally do for getting there for Jupyter Notebook. And every time a new lesson is released, you can go in here and type git pull. And what this will do is it'll check GitHub for any changes to the code. So then instead of needing to go to the page and download it and then copy any changes you made to previous lessons, this will just pull down any changes that were made and it'll leave the code edits that you did intact. So now that we've done that, I'd recommend doing this every time you start watching a new lesson, and I'll try to remember to do this before going into each lesson. From here, we'll type our lovely Jupyter Notebook command, and we can get started. Let's open up lesson 2, since that is where we're at. And lesson 2 is all about control structures. I don't know what that means, but don't show me this anymore. Lesson 2 is control structures. So that's if, elif, and else statements, for loops, and while loops. There are other control structures, but these are the basics. We're going to start with if statements, and this is going to cover if, elif, and else statements. If I say else if, that is the same as elif. It just is easier to say, and every time I try to say elif in a sentence, I have a stroke. So if statements, else if, and else statements, they're all conditional ways to filter out code. With each statement, except for else, you have a conditional statement that corresponds with it. And if this statement is true, then it's going to execute the code that's within the if or else if statement. So here, for example, we have if A is less than B, print lone statement met with very poor grammar and capitalization. So A is 12 and B is 35. So since that's true, it's going to print lone statement met. And you can see that down here. Next, we have an example for an else statement. If A is greater than B, print we shouldn't get this output. Else, first else hit, we hit this every time everything above it returns false. And since else doesn't have a conditional statement, if everything else fails, that's what gets executed. So you can see that down here too. We have if, elif, and else. And so if this failed and this failed, then our else statement gets printed out. But for now, we're just looking at this one. So it's going to print first else hit, 35 is not less than 12. So we're obviously going to hit the else statement. We can see it printed down here. If, else, if, and else, since we're trying to give an example of each item, our else if is going to be executed. So B minus 23 is equal to A. 35 minus 23 is 12. So it's going to print hit the else if. And you can see that here, that statement wasn't true. And since this one is true, our else isn't going to be executed. Here I have a little note about blabbing on and talking about them more. You can use as many else if statements as you want. You don't need to exclusively have these three. You can have 2 else if statements. You can have 3 else if statements. If you really wanted to, you could have 40, even though that's not recommended. You want to try to reduce the amount of else if statements or total conditional statements that you have so that your code is more readable and it's easier to debug if anything is going wrong. I don't know what else I have in here. I have the else ifs. Yeah, we'll move on from that. For loops. For loops are a way for you to iterate through lists of items or sometimes ranges of numbers. For my examples here, excuse me, I have something in my throat. My fruits here is a list of fruits that are strings. And so with this for loop here, what it's going to do is it's going to take each of these items and assign it to itself and then execute the code. So for the first time that it's looping, I is going to be equal to the string banana. And then it's going to print a banana as a fruit. You can see that here. And then instead of moving on to the next line of code here, the result, it's going to loop back onto this for loop and take the next item in that list. So I is going to be equal to strawberry, and we're going to see it print a strawberry as a fruit. And it's going to do that for each item in the list until the list is empty, until it reaches the end of the list, and then it'll move on. Down here we have result equals 5, and I'm going to declare this so that our number is going to iterate, and we'll expand on that in a second. But here we are also going through a range. So instead of looking at a list and going based on the item, it's going to go on a list of numbers that instead of creating that list manually, we're just going to say range 12. And a note about this is it's going to start at 0 and it's going to end at 11. It's not going to go 1 through 12 like we would normally do when speaking a spoken language. It's going to be like I'd previously stated in lesson 1. It's going to start at 0 and then end one number before what we specified. And for the ranges, it's always going to do that. The number that you specify here is excluded from the range of numbers that it's going to iterate over. So for this for loop, we're going to take I in 12, so that's going to start at 0. We're going to take this result and multiply it by 3. And then it's going to print out after however many loops, our result is the result. So after 0 loops, our result is 15. So that's 5 times 3. After 1 loop, since it's going to execute that and then jump back up, it's going to do 15 times 45. We're going to get, after 1 loops, our result is 45. And it's going to do that up until it reaches number 11. So while we're specifying 12, it is still doing 12 loops. It'll just be 0 to 11 instead of 1 through 12. excuse me. The reason I have this statement outside of the for loop is because if we have it here, we're just going to get 15 each time because it's doing the loop and then it's reassigning result to 5. So we're not ever iterating our result. So it's important to keep anything that we want to give value to once outside of the for loop. Otherwise, it's just going to be reassigned its initial value every time. Something else here is that this I is used twice. And that's important because I here is going to be forgotten by the time it gets to here. And this is a little bit on the concept of locality for I in my fruits. It's a string the whole time. By the time it reaches here for our next loop, it's an integer every time. So after this loop finishes executing, Python forgets that I was used or that I was existed. I was existed? What the frick? That I was. Golly, I can't even talk. Let's validate that what I'm saying to you is even true. Print I. Oh my gosh, I isn't forgotten. Everything is a lie. I is not forgotten, but I is reassigned. And since Python doesn't care about what your variable types are, you can do this and get away with it because it's going to be like, oh, it was a string, but now we're making it an int. We're giving it the value 0. And it's going to do that and not care about it. So everything in this paragraph is a lie. Don't even read it because it's not true. But locality does matter, and I'm going to delete that. If you really want to read it and judge me, you can. And you can just go back and pause it and read it. Wow, golly, I don't know what I'm talking about. Okay. For our ranges, I don't know if I mentioned it earlier, but we can specify the values of the range. So here you can see that it's going 1 through 12. But instead of just giving it 12, we're declaring a starting point, and then we're saying 12 plus 1. Really, you can just put 13. Just remember that this ending value is always excluded. It's an exclusive value. The first value, or the initial value, is inclusive. So whatever you specify here is going to be included in the listed variables or listed values. Whatever you specify here won't be included. Instead, what you'll get is this value minus 1. Something you can also do with ranges is specify a stepping point or a stepped value. So if we specify 2 here, instead of counting up by 1 until it reaches 13 or 12, it's going to go by 2. So you press Shift Enter, you see 1, 3, 5, 7, 9, 11. And then since we'll be hitting 13, it's going to stop. It's not going to print that out, and it's going to move on. I left a cute little link here for you if you want to read more about ranges, but that's the basics. While loops. Oh my gosh, let me scroll more accurately. While loops run until a specific condition is met. So right here, a while loop will look at this condition. Our integer here is 38. And while this integer, 38, is greater than 0, run the code within this loop. So it's going to run it, and then once it gets to the end, it subtracts 3. You have to manually specify what you're wanting this to do. So if I were to have excluded this line altogether, this loop would run forever. And every loop is capable of running forever. You just need to make sure that you put in the logic to make sure that loop has an endpoint, that it's not a value that can become infinite, or do whatever you can to add a loop break if you can't predict every value that could be plugged into that loop. So in this case, it's 38. Hey, chill please. It goes down by 3 every time it loops. It will eventually end. You can see this down here because I print out the value of while int. we start with 38, goes down by 3 until we hit 2, and then the next time it runs, or once it hits 2 and it checks, it's going to be the value of -1. So it's not going to run that embedded code again. It's going to finish that while loop, then we'll get off our final result, which is -1. For the take caution, let's see what I have in the take caution. Any loop, for loop, or while loop can become infinite. I mentioned that a little bit here. It's your responsibility to make sure it's going to end at some point. Infinite loops will run until your computer runs out of resources to keep going, and then your computer will crash. Or in the case of some languages, it'll fill up the virtual machine for that language. The next caution is runtimes. With loops comes greatly large runtimes. This is dabbling in discrete math a little bit, but as you start to embed loops, and the example I use here is for loops, the execution time for your code is a non-linear increase. For loops, if you have embedded for loops, it increases by, if we were to use n for the amount of times that it were to loop, n times n. So if we have a for loop that's supposed to loop 10 times, then we put another for loop in there that's going to increase, or that's going to loop 10 times, then our total loops that are going to be run are 100. And so once you start embedding for loops, your code execution time increases greatly. The same applies to while loops, but it's not an exponential increase, or sorry, a quadratic increase. For loops, it'd be a quadratic increase. I believe while loops are a logarithmic increase. So not as bad as quadratic, but it's just something you need to keep in mind if you're trying to increase the efficiency of your code. Practice problems. All right, I don't hold your hand as much on these because at this point I'd hope you know how to create some variables. For number 1, we create a series of if statements that include an if, at least one else if, and an else statement. So you can add as many else if statements as you want. You just need one if statement, one else statement, and then you need at least one else if statement. So we'll go with 2. We're going to declare A equals 57, B equals true, C equals a string called string. So we're going to make our if statement false. It's not going to run the code within our if statement. So we're going to say if not true, so it's never going to run, print this is literally impossible. Also, before you start copying what I'm typing here, go try it for yourself and then refer to what I've done if you start to run into any problems. So far, I've only written one if statement. So pause it now. I'm giving you half a second to pause. Do this yourself before I continue. We'll do an elif, and we should make this one false. Maybe we'll make this false. Actually, let's make this one true. If A is less than 100 and B. So A has to be less than 100 and B has to be something that equals true. Our B variable is true, so this should execute. Print, I did it, Dad. Then else, we'll print something that's not going to ever print. Here we are alone again. Here we have down here, I did it, Dad. This is our true statement. C was never used. We're just going to throw this there just so it gets used up, even though we're not going to see it. But this would be acceptable. you'll need to declare your own variables yourself and then figure out what kind of logic you want here. You can refer to lesson 1 for other operations you can do, such as the and, or if we really want to, we can throw and not, and we'll print our C. And then there are other comparison operators that you can use other than, less than, greater than. I think I used greater than earlier. That's beside the point. 2, create a series of if statements that includes an if and else if. Have code after the else if that will always be executed regardless of the if and else if statement outputs. So we can take these if you really want to be lazy. Let's clean this up, get rid of unnecessary things. Actually, we don't even need those because those are going to be retained. And let's make this one true. I did it, Dad. But then we want some code that gets executed. I'm using a lot of print statements. That's fine. If there's something else that you think that you'd like, or that you would like to put in there instead of a print statement, go ahead. I'm just doing this for simplicity's sake. Print, I will always run. Or, I did it, Dad. I'm going to get some milk. Love, Dad. So this one will always be executed. Else statement doesn't exist. This is just to show that you can run these without an else statement, and that there is a time when you do want to use those. Else statements aren't always necessary, and maybe for logging purposes, you might want to include one here just so that it knows that it skipped a few lines or didn't kick, that conditional statements weren't executed. But for now, ignore the else statement, add something here that will always get run regardless. Create a list and for loop that interacts with the list. The list should include at least 5 items. We're going to do electric cars for mine. And we'll start with Model 3. Ooh, actually, Model S. Model 3. Model X. Model Y. Cybertruck. We're gonna have some fun with this. For I in electric cars. Once you have that, your for loop is created. And what I want to do is print out sexy with a 3. So we're going to do print. We'll do I sub -1. This is referred to as string manipulation, I think, probably. I think there's a better word for it, or a more computer sciencey word, but we're going to just go with that. So this is going to be pretty cool, pretty funny, because we're going to get sexy and then a K at the end because of Cybertruck. And that would be acceptable. Let's add an exclamation point to Cybertruck. Because it's not out yet, we're just yelling at Tesla because they need to get their act together. I'm just kidding. I think Tesla's a cool company. So sexy exclamation point. Create a while loop that ends when a number input is greater than 150. So you can do this a few ways. You can make it absolutely horrid and wretched on yourself if you really want to. Actually, the code will be the same. It'll just be more work on your computer. So we'll do starting int equals 1. If you're copying me because you got stuck, you can make that number whatever you want. We'll go while starting int is less than 150. We're not going to do less than or equal to 150 because we want it to be greater than 150 before this ends. Something that I didn't mention with any of these, we're back to lesson time, is that you don't need to always have parentheses. So like all of my if statements they don't have parentheses. This is the same exact thing, and that'll still be accepted. For while loops, I believe I used parentheses, and I think I'm 5% sure, very sure of myself right now, that that will run without any issues. While starting int is less than 150, we'll do print, we'll do starting int plus equals 2, we'll iterate by 2, and then let's throw an if statement in there. If starting int is greater, let's see. Starting int equals something. 125. Print. Nailed it. Yep. That ended there. And just for fun, we're gonna print our starting it. But as you can see, the while loop still ran without the parentheses. My 5% confidence in myself paid off, and our while loop ran 75 times. Not that you would have seen that, but since it iterated +2 every time, it would have run 150 divided by 2. We can print our starting int just for fun. Just so we can see how many times it's going to run. There's all of them. Nailed it at 125, printed 151 again at the end. Create an infinite while loop or infinite for loop. This is super simple. We can just do while true, print, and forget how to make a string. Print help. This is going to just go on forever. Even though this doesn't look like, I don't actually know if it is running. Jupyter Notebook might have stopped it. Yeah, it is. It is still running. That's what that little asterisk means. But it's printing help forever and ever and ever and ever and ever. So we're going to crash my browser or something here in a second and then stop it. I don't actually know how to stop it, so we'll see. We're going to discover this together. Interrupt the kernel. Interrupt the kernel. Should be stopped now. You can tell because it says ln12. Oh, shoot. Sorry. You can tell because ln13. And then if we scroll all the way down to the bottom, we still have help. Because I don't know if Jupyter Notebook's made to handle all that. But that's the end of the last problem. Let's give an example of a for loop real quick if I can find out where we're at. Let's clean some of this up so we have less. That's 9. Create an infinite loop or I in range 10. Oh, whoops, incomplete input. Sorry, my bad. Shift entered too early for I in range 10. What we'll do is print help. 1 exclamation point. We're not feeling as in danger this time. And then I equals 0. What? That wasn't infinite. Can you make infinite loops with for loops in Python? For loop infinite Python. Are infinite for loops possible in Python? While true, past, def infinity, while true. Oh, interesting. Oh. Okay. You don't need to do this. I'm going to change it to just a while loop. Infinite while loop. While loop loop. Oh. Infinite while loop. But this is going to be fun. So you're going to see a little bit of shoot, what am I talking about? Module function declaration. We're going to say function declaration. We're just going to copy and paste this because that's all programming is. Copying and pasting. Ah, no. Premature shift enter. But instead of pass, we will print help. Aha! All right. That would be a little more of a puzzle if you really wanted to do that. I'll leave that. I'll leave that in there. I'm going to delete that other paragraph where I was an absolute fool talking about if statements. But that would be a true challenge for you to figure out. Applying things that you haven't even learned yet in these lessons. And then applying them to a for loop. Or inserting them into a for loop. But anyways, that's lesson 2. Message me if you have any concerns, questions. If you want to bash on my voice or something, that's fine too. And have a good day. Bye.